Thank you, Nathan. Good morning, everyone. I'm absolutely thrilled to be here to discuss a topic that is shaping the next wave of AI, which is physical AI agents. But before we dive into the technical depth of it, I want to introduce myself. So I'm Nyanika. I'm an MBA candidate at Cornell right now, with strong focus on product management and technology. So previously, I was working as an AI ML software engineer at IBM, and I was building AI powered solutions in Industry 4.0 and Gen AI. And my work has spanned across computer vision, models for robotics to enterprise AI solutions. So today, we will decode physical AI agents, what they are, how they work, where they are being applied, and what the future holds for them. So AI is no longer just software, and it is increasingly becoming a more autonomous and capable of interacting with the real world in a meaningful way. By the end of the discussion, I my goal is that you walk away with something of deeper understanding of physical AI agents, whether you are an AI researcher or engineer or a business leader. So let's get started. So what are physical AI agents? In essence, these are basically autonomous systems that integrate AI with physical embodiments, enabling them to perceive, reason, and act within the real world environment. For example, imagine a self driving car, a robotic surgeon, or an autonomous drone. These are all physical AI agents. They're not only analyzing the data in a real time, but also interacting with with their environment physically. So at their core, they work on three fundamental capabilities. One of them is perception, which is they need to see, hear, and sense the environment. Second is computation and decision making. So they must interpret the data that they are collecting from the environment and make real time decisions. And actuation, which is making the move to interact with them physically. So let's break down each of these different pillars of physical AI agents. So the first one is perception system, which is the eyes and the ears of AI. So a physical AI agent is only as smart as its perception system. Um, for example, an autonomous vehicle is speeding down a busy city street. We all know about Waymo. And it needs to distinguish between pedestrians, traffic signals, road signs, and sudden obstacles all in real time. And this is where advanced sensory systems come into play. For example, visual sensors like RGB, infrared, and depth cameras, which allow AI agents to see and identify objects with incredible precision. And there are also LiDAR and radar systems that help them to create a 3D spatial map, which can detect distances and velocity of surrounding objects. There are other sensors like inertial measurement units, which track an agent's orientation and movement, which are crucial for drones, humanoid robots, and self balancing systems. Other sensors like tactile sensors help them to sense touch, pressure, and temperature, which are like human like dexterity. And other than that, microphones and audio sensors are used for speech recognition and environmental sound analysis, making voice controlled assistants much smarter. Now, the real power lies in actual sensor fusion, where data from multiple sensors is combined to create a more robust and accurate interpretation of the surroundings. This is what makes AI agents create informed and real time decisions. The next foundation is the cognitive architecture, which is basically the brain of AI agents, where they process, interpret, and act on that data. Um, a physical AI agent's brain is designed around one knowledge representation as to how is the data being organized, and it has to be in a structured and a logical way The second is the decision making algorithms. So these are deep learning algorithms like deep reinforcement that enable AI to optimize the actions based on the outcomes. So reinforcement learning, which is inspired by human learning, enables them to continuously improve the responses based on the previous errors. Um, think of like a robotic warehouse system that uses deep reinforcement learning to dynamically optimize its movements. It needs to reduce energy consumption, increase efficiency, and adapt to workflows changing in real time. And this is the ability to learn and improve over time is what sets AI agents apart from traditional programmed robots. The next foundation is the actuation system, which is the motor skills of AI. So once an AI has agent has processed the data and made a decision, it now needs to make physical action on that decision. And this is what brings us to the actuation system. So one of them is electric motors. So it needs to have robotic electric motors in robotic arms and even in self-driving vehicles. Um, there are also hydraulic and pneumatic actuators which are used in heavy duty industrial robots and exoskeletons. Um, Another one is soft actuators, which mimic biological muscles, allowing for natural movement and adaptability. So these are essential in humanoid, robot, and prosthetic AI agents. A great example of this is how Boston Dynamics Spot Robot uses real time control algorithms to perform highly dynamic movements, for example, like jumping, backflips, and even running. And the combination of all these three, perception, cognition, and actuation, is what makes AI agents truly autonomous. So, coming to the current real world applications of AI agents, um, one of them is, of course, healthcare. We have heard about AI powered surgical robots like Da Vinci, which are revolutionizing manually invasive procedures. Moreover, autonomous vehicles, we've all heard about Tesla and Waymo, which are leading the race in self driving technology. Other than that, they're also used in industrial automation to move towards Industry 4.0 from manual industrial settings. And it helps basically in robotic processes and helping with predictive maintenance as well. Moreover, it is also being used in smart agriculture, where the farming equipment is equipped with AI and it optimizes the irrigation and crop yields while also minimizing the use of water and pesticides. Some other examples like defense and security, how autonomous military drones and robotic surveillance systems are advancing national security, as well as space exploration. NASA is using their Perseverance rover, which is autonomously exploring Mars using AI. So the integration of AI with robotics is no longer futuristic. It is here now and evolving at an exponential pace. But of course, it has its own challenges. And one of the biggest challenge is safety and reliability. Can we really trust these AI agents in high risk environments? Um, let's say it's on the road and it's an autonomous driving car. We need to ensure that there is less than 1% error. Even if there is 1% error, it can lead to thousands of accidents per year. Moreover, we also need to address the ethical concerns. For example, how will these AI agent robots make ethical decisions when uh, they are using so many sensors, that they are using microphones, they're using cameras, and these surveillance data needs to be handled very carefully. Of course, when these AI agents are being used in the real world, there is also the fear of job loss because manual processes are being replaced. For example, people working in manufacturing settings, they are being replaced by robots on the assembly line. So, moreover, autonomous weapons, how can we ensure that these weapons are used for national security and not for other things, and and hopefully they don't really act according to their own uh, will and power, right? um, the other thing is legal and regulations. So we know that governments all over the world are trying to create frameworks now that they realize the power of AI. But who is legally responsible when an autonomous AI agent makes a mistake? Is it the robot? Is it the person like operating, let's say, an autonomous vehicle, or is it the government, or is it the company? So these are all good questions we should ask while we are harvesting the power of AI. Having said that, this technology is currently being used by top companies all over the world. And some of the latest developments, which is shaping the future of physical AI, can be seen through the NVIDIA's Cosmos platform, which is a revolutionary toolkit for AI powered robotics. And recently, even the CEO of NVIDIA had talked about how he believes physical AI agents is the next big thing. And Cosmos basically is a powerful suite of tools that integrate the World Foundation models with advanced simulation capabilities, which allows researchers to build more intelligent, adaptable AI agents. Moreover, there are also like bio-inspired robotics, which is the merging of biology and AI, that is revolutionizing exoskeleton and soft robots. There are also other examples that are being used by Llama, which is the open LLM family, and also Salesforce, which is using the AI powered retail platform that is transforming the retail workforce management with AI augmented solutions. So I would want to talk about the emerging the emerging trends other than the human robot collaboration, and I believe that these AI powered physical systems will become as common as smartphones. I want to like really leave you with this thought that AI is not just about machines replacing human efforts, it is about amplifying the human potential. And as researchers, business leaders, and engineers, it is our responsibility to ensure that the AI serves humanity in the best possible way. So I think we need to continue pushing the boundaries, questioning the ethics, and shaping the AI revolution together. Thank you so much for your time, and I look forward to any questions.
Thanks so much, Yanika. This was like an amazing presentation. I personally learned a lot about like physical AI and the agents, and I feel like you're right. In the future, when you kind of have this physical workforce or robots, there's going to be like all these interesting applications of AI, and it is kind of worth thinking about and discussing now. So, thanks so much for your time.
Thank you, Nathan. Thank you for having me.